Welcome. Today we will be working on solving absolute value inequalities. So mainly if you guys just need a refresher or if you were out today that we learned it, here we go through the notes. So graphing all solutions to each of the following on the number line, then write your solutions as inequalities. So let's remember that absolute value is the distance from zero. So what this question is asking, or the absolute value of x is greater than 0, we're saying that the distance from x to 0 is greater than positive 3. Okay. So if we look at our number line, is 1 more than 3 spaces away? No. Is 2? No. Is 3? No, but is 3.1? Yes. So we're going to have an open dot at 3. 4 is greater than 3 spaces from 0. So we're going to shade towards 4. Okay, so now we went to the right, but we also need to go to the left. So -1 is not more than 3 spaces from 0. -2 is not, but -3.1 is. So again, we're going to have an open dot at -3. And this time we're shading towards -4 because -4 is also 3 spaces, is greater than 3 spaces away from 0. All right. So now we're going to do the same thing with the absolute value of x is less than or equal to 2. However, this time we're looking for the distance from x to 0 is less than or equal to 2. Okay, so 1 is less than 2 spaces away, but 3 is not. Since we have equal to, we're still going to have a closed dot at 2. Okay, same thing for -2. -1 is less than 2 spaces away from 0, but -3 is not. So we're going to have a closed dot again at -2. And this is going to be connecting. Okay, if we go back to our first one, this compound or this graph looks like the or compound inequality, and that's exactly what it is. It's x is less than -3 or x is greater than 3. Our solution is a compound inequality. Okay. This one, again, is a compound inequality. However, this time it is and. So we have -2 is less than or equal to x, and x is greater than or equal to 2. Or sorry, less than or equal to. Or we could also have x is greater than or equal to 2, and x is less than or equal to 2. Or writing it as a compact version, -2 is less than or equal to x, which is less than or equal to 2. All of which are appropriate representations of the same inequality. Okay. All right. Moving on to our notes, or to our rules for today. Once the file decides to open. So our rule, to solve that absolute value of a is less than b, we solve a is less than b and a is greater than -b. So whenever you see less than, think of an and Okay, so less than. Okay, to solve A is greater than B, or the absolute value of A is greater than B, solve A is greater than B, or A is less than negative B. So for this one, think great or. Less than and great or. So now our steps for solving these absolute value inequalities. They're exactly the same as our steps of solving absolute value equations. So we're going to isolate the absolute value. Expression. Then we're going to write two inequalities. Okay. Remember, less than great or. Okay. And then when we are solving these, one of them will stay the same. And one we will keep flip and change. We'll go over what that means on the first example. Okay. Step 3 is to solve each inequality. Step 4 is to check by plugging numbers back into the original inequality. Okay. So let's get into an example of this. Again, you can pause whenever you need to. So solve the absolute value of v minus 3 is greater than 4 and graph the solutions on a number line. So our first step is to isolate the absolute value. This one has already been isolated, so we can go to our second step of setting up two inequalities. So one, we keep the exact same. V minus 3 is greater than 4. Okay, now looking at our original sign, that's greater, so that means we are going to have an or inequality, great or. Right? Now here comes the keep flip change. We're going to keep what's inside the absolute value, so v minus 3. We're going to flip our sign. We're going to change our positive to a negative 4. So our positive 4 now becomes a negative 4. Now we solve them just like we know how to. So we add 3, and we get v is less than 7, or sorry, is greater than 7. V is greater than 7, or, again, add 3, v is less than negative 1. Okay, so going to our number line, negative 1, negative 3, go 3, 7, 9. We're going to have an open dot at both negative 1 and 7, as it's not equal to. 7, we're going to shade towards 9. And negative 1, we will shade towards negative 3. Please check out the next video for the other examples.